In this presentation, we will begin by outlining the scope of the digital implementation of the project and proceed by discussing some issues and cautionary tales when it comes to recording and presenting ethnomusicological data. We will proceed by presenting our efforts to provide a data model for the management of the collected resources and develop the project's repository alongside spatial data presentation solutions. So the primary objective of InterMusiG is the study of the spatial and temporal dimensions of intercommunal musical relations in late Ottoman Istanbul. As mentioned in previous presentations, key transformations in the field of music during this period had a significant impact on the geographies of musical activity in the city that the current project aims to capture. With respect to the deliverables of the project, this comes down to activities organized into two different work packages. Under Work Package 2, entitled Development of Research Methodology, we try to research best practices on historical and ethnomusicological data modeling, specify the requirements for the recording methodology, and implement a data model that would allow future extensions, data interoperability, and geographic awareness. The research is summarized in Project Deliverables 2.2 and 2.3 shown here. Under Work Package 6, entitled Mapping Intercommunal Musical Relations, we target the creation of several thematic mappings to highlight aspects of intercommunal musical interaction in Istanbul across space and time. Musical spaces, events, and performance should be linked with actual geographic locations using GIS solutions and analyzed for their spatio-temporal distribution and succession. A minimum of 3 thematic maps will be integrated in the project's web portal. Work under Work Package 6 is currently underway, and some preliminary proposed solutions are presented. So digital humanities projects can be quite difficult to implement, not so much for the restrictions of technology as for the nature of archival research and historical information. First of all, archival research is subject to source variability, selection, and targeting. At the beginning of a project, it is often difficult to consider what kind of information is available in the archives and how it should be recorded. Sources need to be scanned through for historical information, which can be very unstructured and often vague or incomplete. In addition, data recording needs to be consistent, especially for projects like these that contain multilingual sources. The digital success of such a project is also directly related to the ability to provide the necessary data structure so as to be comparable with other datasets and minimize fuzziness. However, at the same time, balance must also be achieved between machine rigidity and recording flexibility. Finally, when it comes to digital solutions, there are several ways to do things with very variable outputs, as you can imagine. Originally, we tried to understand the domain under study, which takes a thematic view of historical research, namely the identification of key places where musical activity takes place in late Ottoman Istanbul, the protagonists and their main life facts, as well as their relation to important cultural achievements of this time in the form of composed music and songs. The project's approach was that by recording information on all of the above, certain intersections would appear, allowing researchers to reflect on the intercommunal interactions. We began by discussing the sources and understanding how these are scanned through by the researcher to extract the relevant information. We realized that diverse sources provide different information for distinct aspects of the collected material. For example, information on musical events or places of reference can be found in memoirs or other variable narrative sources such as guestbooks, while information for the identification of key musicians active at the time can be pursued in formal archives like those of the Greek Orthodox community or the Ottoman State archives. We engaged in discussions with the project's researchers to understand how they work, what type of information they look out while reading these sources, and how they plan to register this information in tables and data fields. We also discussed what are the digital infrastructure expectations, what kind of information needs to be presentable, and how the visualization of musical interactions is envisioned. Needless to say that much of these discussions have been repeated over the duration of the project in order to implement improvements in both data registration and presentation. We proceeded by reviewing digital solutions used by similar projects and understand their advantages and disadvantages. Examples reviewed were grouped under 5 application categories or relevant technologies. Online repositories and musical databases included technologies like Omeka or Drupal and applications such as the CMO. Metadata models that are used in collections management and bibliographic information. Graph visualizations that discuss the evolution of networks over time, including Onur's very informative research. Web mapping applications in the field of digital history, such as Digital Harlem or the Istanbul Urban Database. And finally, musical geographies containing spatio-temporal visualizations of musical histories and exploring the integration of cartographic narratives. We realized that there are various paths to both data management and presentation, from simple content management systems for presenting small datasets to mid-scale solutions that link data management to presentation, and fully repository-scale implementations targeting data preservation and dissemination. Rather than choosing by technology, we decided to focus on metadata provisions and facilitate a degree of information standardization that can prove key for the long-term preservation, interoperability, and potential aggregation of the informational output of the project. We realized that the emphasis of the project is not on collection management, not on a closed report that can be investigated using geovisualization methods. Rather, the greatest asset of the project is the primary information collected and the capacity to link this information to other projects and get it more complete, allowing its spatio-temporal investigation. In a sense, then, the thematic maps by the project can be used to provide insights or scenarios about how this information can be presented using various tools. So above all, we try to concentrate on thoughtful data modeling aspects that would enhance the recording effort of the historians and allow experimentation in terms of its presentation using digital mapping. To understand the spatio-temporal complexities in our data, we turned into widely used ontological models in the fields of cultural heritage and bibliographic data. The CIDOC-CRM is a standard ontology facilitating the interoperability of heterogeneous cultural heritage information in museums and collections. The model is event-centered, meaning that the documentation of activities allows the connection of people, places, objects, and ideas. Recently, several extensions have been developed to allow for domain-specific implementation with enhanced expressiveness. One of these is the FRBRoo, an object-oriented formal ontology intended to capture and represent the underlying semantics of bibliographic information. The combined use of the two allows the description of processes relevant to the performing arts that must separate the creation or the performance of a work with its actual materialization in a publication. Using these two, we try to retrieve the basic elements of our data model. In essence, we try to record information about musicians who participate in musical encounters happening in specific venues or places once or regularly. Under musical encounters, we also include musical events marking creation or recording activities that result in musical objects, such as the publication of songs or compositions. Information about these events, actors, and places or objects are collected from various information sources. The main elements of our model and their linkages through expressed relationships mean that each piece of information retrieved from the sources is stored in a conceptually proper data field or table. So to give an example, the musician Sermuezin Rifat Bey was born in 1820 in an unknown location and died in 1888. He belongs to the Muslim community and he is known as a singer. Although we don't know when he joined the Ottoman Palace Instrumental Ensemble, we know that he left in 1861. We do not know the exact location of his residence. He is documented in the source entitled Elhani Aziz Sultan Abu Aziz Devrinde Saraida Musiki. I'm not very good, in pronunciation. In our database, this is the source that we used, and in our database, he is recognized using a certain code. Now, Sermuezin Rifat Bey participated in musical performances of the Ottoman Palace's Instrumental Ensemble, which took place at the Topkapi Saray, located in Kankuntaran in the Fatih district, during the year 1870-1871. These regular events occurred in the presence of other musicians, such as Tanburi Osman Bey, in the role of the head of the ensemble. You can hear he is here. The event is documented in the Ottoman State Archives. Now, Sermuezin Rifat Bey is credited with the composition of the song Kyordurum Kyunden Peru, that is characterized by the Bayati musical mode and the Duyek rhythm. The song was included in the musical anthology by Ioannis Kevelis, published in 1872 in Istanbul. Under the present research project, you can see it here, the publication in Istanbul and the description of the year. Under the present research project, the song was performed last month in Athens by the project's ensemble and was recorded in order to create a modern audio version of the song available through the project's website. So, the combination of different actors, places, and objects through musical encounters and other recording or publication activities provides the backbone of the logical model of the project's database. However, achieving semantic clarity does not come without costs. The implementation of this type of model comes at a cost of established data registration practices. In order not to delay the project, we try to proceed with platform development in parallel with data recording, using the means that the researchers were most accustomed with. So in a sense, we transformed the project workflow from a direct registration procedure into largely a data migration process. To ensure that no bottlenecks would appear later on in the project, we established a set of documentation guidelines for the correct entering of information and provided multiple fields for certain items to account for original and derived or presentation mode information, as well as for different notation systems used. At the moment, we are finalizing data cleaning and data harmonization that will allow us to migrate the project's entire data content to the aforementioned data structure. In this process, we take extra care to standardize expressions and map existing terms used in the database, such as place names, to thesauri or other linked data sources, such as the Thesaurus of Geographic Names by the Getty Institute. With respect to implementation technologies, we decided to go for a robust database solution, PostgreSQL, that can be combined with PostGIS for handling the geospatial information. Data collected are currently imported into the respective data structures. On top of the database background, a Drupal-based CMS is used to manage the building blocks of the project's website and provide separate roles for site administration and data entry. The website front end is being complemented using Angular, a platform for building mobile and desktop web applications. Communication between the database and the front end employs Node, JavaScript, and GeoServer. The entire architecture is built on open source components, supports complex models with interrelated content types, like videos or images, etc., and allows design and implementation flexibility, at least some. So far, with respect to thematic mapping, we have tried to summarize a portion of the data and start getting an understanding of potential spatial patterning. In this preliminary visualization, you see the distribution of music venues by district. The example shows an inherent problem in geohistorical applications. In many cases, we have general and not exact locations in order to make sense of the data. We have to summarize information in the next available level, in our case, the district level. In this first attempt, you can see that most of the music events recorded by the projects are happening in Fatih and Pera, closely followed by the area of Haskui. However, when it comes to presenting the known residents of the musicians, we notice that their living geographies are different. Not that many live closely to where they work, and we can imagine a certain degree of mobility, especially since in many cases musicians are present in multiple events happening in different locations in the city. To get an idea about community-based distributions, this diagram shows the number of musicians recorded by the project by district and according to the community they belong. In the two pies below, two things become apparent. First, that the majority of recognized musicians by the project so far, at least the data that we have already used for this example, come from the Greek Orthodox community, and that the number of musicians for whom we have a reliable knowledge of the residents at the district level is only about 27%. This is the total of musicians that we have, 561, and we only know the district location of the residents for 27%. This example comes only to serve as a reminder that this project, as much as any other historical research, suffers from both data precision and potential partialities caused by the original sources used. However, our investment in data structures and data modeling can perhaps allow further data additions from targeted sources or other relevant projects that can augment inclusiveness and also precision. So to conclude, when it comes to musical geography, several data requirements must be investigated. The first suggestion is to know your data. This means identifying the sources and realizing what needs to be recorded and what doesn't. The second suggestion is to get to know how the researcher works. Rather than propose solutions that may prove inflexible, we need to reflect on our practices, seize the advantages and disadvantages, understand what we want from the data, and how the historian gradually creates a mental image of their domain. Metadata provisions are key for data dissemination, as well as their survival, aggregation, or potential reuse. In this respect, data modeling is important for providing the intended functionality, and in our case, it builds on the centrality of events and activities as data items. The documentation can act as the linking element of separate bits and pieces of information on actors, objects, and places. A final suggestion is to acknowledge potential data biases and incompleteness. In many cases, this means that rather than fixating on the quantification of incomplete information, it may be much more useful to focus on selecting representative information based on qualitative criteria and presenting this through alternative solutions, such as cartographic narratives or story maps. This means that geospatial representation should be selective and used to present aspects of the study results rather than, let's say, an all-encompassing high-end visualization data pool that suffers from incomplete information. We hope that the integration of both data repository and web mapping services within a dedicated website with complementary material and the steady flow of selected themes to be explored during and after the project can further enrich the permeability of the project's research results to a wider audience. Thank you. Thank you very much.